All right, we're going to continue today looking at law of sines. This is day 2. If you have not already participated in the lesson for day 1 or watched a lesson video for day 1, make sure that you do that before proceeding here. So we're going to continue to talk about solving an oblique triangle. Today our focus is going to be case 2. If you remember in our day 1 lesson, we had 4 cases for solving oblique triangles. We did case 1 on the first day. Case 2 is the side-side angle case where we're going to be given one side, we're given another side, and then we're given the angle coming after it. And we actually call this the ambiguous case. When we start to go through the different situations here that are possible, you'll see why it gets that name. So for the side-side angle, the easiest way for us to think about this is let's suppose that the given angle is always this one here in the lower left. Suppose that we're given angle A. You're going to be then given side A and then also side B. So side, side, angle. Notice in my drawing here from the top of my triangle, I'm drawing a dotted line straight down representing the height. So just imagine that height distance. That's going to be important when we start to think about some of our different situations. So side A, you'll see it's not drawn here yet. Right now it's invisible. I'm going to draw it for you here in a moment because there's different possibilities for this situation depending on the length of that side A. So I kind of sometimes call this side A the swinging side, so I'm going to go ahead and draw that on here. And this tool allows me really nicely to move this side around as long as I hold on to it with my mouse and don't let go. If I let go of it, I might have to erase and start over. But one possibility is if side A, oh shoot, I just let go of it, hold on. Side A is less than the height. So if side A is less than the height, you'll see that it's not long enough to make a triangle. And it could pass through the height. You could put it all the way over here to the other side. It will never touch. And so one possibility is that there's actually no triangle that ends up being formed. Another possibility is if side A is equal to the height. So if it's equal to the height, you end up with one triangle, and it happens to be a right triangle. Okay, a third possibility is if side A is longer than the height. So notice how it's a little bit longer than the height. Oops, I let go of it. This might be a little harder. In class, it's easier for me to demonstrate because I actually use a ruler to demonstrate the swinging side. If it's longer than the height but less than side B, it's going to actually form two triangles. One triangle is this little obtuse triangle. I'm going to have to redo this. Okay. I'm sorry. This is frustrating. Okay. Two triangles are formed. So if it's longer than the height, one triangle would be if you move the side out like this. Longer than the height, but still less than side B. The second triangle is over here. So just imagine that like long, skinny, obtuse triangle that you see there. So that's the second possibility. All right, a final possibility is if side A, it's not letting me get rid of it. There we go. The final possibility is if side A is actually longer than side B. So I'm going to measure it out to show that it's longer than side B. Oh, this is not ideal. I'm sorry. Okay. Longer than side B, there's only one triangle that can be formed, and that's if you move it all the way out here. Okay, so I like to kind of start this lesson off showing you those different possibilities with the swinging side because that's going to help to make the chart make more sense that we're about to look at. So this is so the situations we looked at, that's if angle A is acute, so meaning that angle A is something less than 90 degrees. So if angle A is acute, let's go ahead and do some labeling here. So this is going to be angle A, this little side over here is side A, this would be side B, and then this is going to be our height. So notice the condition. If side A is less than the height, we get zero triangles. So imagine this side here, no matter how you swing it or move it, it's never going to be enough to make a triangle. Second situation is if side A is equal to the height, you get one triangle, and it happens to be a right triangle. All right, third situation. So this is if, let's look at the condition here. If side A is greater than the height, but less than side B. So if it's greater than the height, the first possibility is that it goes out like this, so that's one possible triangle. The second possibility, so because it's still less than side B, it could pass through the height, making this little obtuse triangle right there. So two possible triangles for that situation. And then the last one is if side A is greater than side B. So this is actually the only scenario that's not dependent upon the height. You don't need to find the height. If side A measures longer than B, there's only one triangle that can be found, and it's going to look like that. Okay, we also have two situations if angle A is obtuse. So let's go ahead and do some labeling here. So this would be the given information. Angle A, obtuse, means that it's greater than 90 degrees. Side A, this would be side B. So if side A is less than side B, or even if it's equal to side B, it's another case where it's going to be zero triangles. So you can kind of see in the picture here, you can imagine like there's no way that it's going to be long enough to attach unless it's longer than B. If side A is longer than side B, yep, it works, and that's just going to give us one triangle. It's a little bit easier to think about our situations if angle A is obtuse. Okay, so let's try this out. We're given some information. Notice that there's not a drawing on this one, so we actually need to be thinking about making our drawing, and we're going to kind of start by thinking of categorizing it into one of these situations and really determining how many triangles there are, if any. So I always start, so A, in this case, A is 122 degrees. We want to always start by determining if that angle A is obtuse or if it's acute. So because it's an obtuse angle, we're going to want to draw our starter triangle something like this. Okay, so I'm going to label this as angle A, and on the inside here it's 122 degrees. Okay, then I'm going to look at side A compared to side B. So side A is greater than side B. 23 is greater than 11. So this is going to result in one triangle. And so I'm going to go ahead and connect a straight line right there. So this is side A. I'm going to label that's 23. This would be side B, which is 11. Okay, so that's our given information. The missing information that we're trying to find is going to be angle B, angle C, and side C. So remember, when we're solving these oblique triangles, we're always given three pieces of information, and then we're looking for three pieces of information. Okay, so thinking about using the law of sines, we know the full ratio, sine A over A, because we know angle A and we know side A. The next one that we can work on finding is going to be angle B, because we actually don't know anything about angle C or side C, so we don't want to do anything with that because it wouldn't get us very far. But we do know, sorry, I started filling in the numbers. Let's just go ahead and write that as B. We do know at least one piece of the ratio for B. So let's go ahead and fill in the starting information here. So notice this is a different first step than what we did in class on the first day. On the first day, we found the third angle measure. But we don't have enough information to do that here. So even though we know that all the angles have to add up to 180, we only know one angle, so we can't do anything with that. All right, so let's go ahead and cross multiply. So we get 11 sine 122 is equal to 23 times sine B. And then we'll go ahead and divide both sides by 23. Okay, so another big difference from what we did in class on the first day is that now we are trying to find an angle rather than a side length. All we know is that the sine of the angle is equal to this number. So what we're going to have to actually do is think about doing an inverse sine. So the inverse sine of that number, and I'm just going to write the whole thing down. Don't type anything into your calculator until the very last step. That's going to just ensure the accuracy of our answers, so we're not doing like rounding upon rounding throughout the process. So angle B, so if the sine of some angle is equal to a number, we've learned back in chapter 4 that the inverse sine of that number will be equal to our angle. So there's actually a way to do the inverse sine on our calculator. You're going to do it by pressing second sine. So your inverse sine there is going to show up, and then so notice how there's a parenthesis at the beginning. We're gonna do a lot with parentheses. So I'm going to add another parenthesis to be around the numerator. So 11 sine 122. Okay, so I'm going to close the parenthesis around the 122. I'm going to close the parenthesis around the numerator. Now we're going to divide that by 23, and then do one more parenthesis to close it from the very initial starting one. Let me just double check to make sure my mode is in degrees. Yes, it's in degrees. Okay, so this will let me go ahead and press enter. All right, so here's what we're going to do with our angles. So remember on the first day we talked about how we're going to round all of our side lengths to 1 decimal place? Well, with our angles, we're going to round all of our angles to the nearest degree. In other words, the nearest whole number. So we're going to say that angle B is 24 degrees. And let's just make a note here that we're going to round to the nearest degree, meaning the nearest whole number. Okay, so as soon as we find something out, we're going to go to our picture and we're going to fill it in. So now we know that angle B is 24. Okay, now what do you think we're going to do for the next step? We know 2 angles. What could that help us get? If you're thinking about the third angle, you're exactly right. So that's going to be our next step, is to find the measure of the third angle. And in this case, that's going to be angle C. And we'll just do that simply by subtracting the 2 angles that we know from 180. So we end up getting that angle C is 34 degrees. So let's go ahead and label that up here as 34. Now we have all that we need to find our last missing side, which is going to be side C. Okay. For your law of sines ratio, technically you could use the A ratio or the B ratio. I would still use A just because that was the given information and we didn't have to do any rounding. So sine A over A is equal to sine C over C. So we'll go ahead and fill in what we know. So sine 122 over 23. And angle C was 34, so sine 34 over C. We'll go ahead and cross multiply. All right, and then divide both sides by sine 122. Okay, and this is the nice one when you type it into your calculator, just like what we did in class on the first day, because we're solving for a side length. So we'll just go ahead and type it in, still do parentheses around your whole numerator part, and because it's a side length, we're going to round to 1 decimal spot to the nearest tenth, and we end up with 15.2 feet, which we'll go back up and label this back in our picture. Okay, next problem. Solve the triangle. All right, so we're given angle A, we're given side A and side B. So let's go ahead and start off by checking to see if angle A is acute or obtuse. This is an acute angle, so that means we're going to want to think about those 4 situations with the swinging side that we started off talking about. So I'm going to draw kind of the basic starting point of how I draw this. Looks like this. I always put in my height unless side A is longer than side B, in which case we don't need the height, but in this case A is still, it's less than side B, so we need it. So let's go ahead and label what we know. So angle A is 72 degrees. This over here is going to be side B. And then our swinging side over here, since we're not sure what the situation is yet, I'm not going to connect it yet because as we saw at the start, there are a few different possibilities. Okay, let's go ahead and label our heights. So unless side A is greater than side B, we need to find the height for our first step. So here's how we do that. Notice how this makes a 90-degree angle. So this is a right triangle. Since it's a right triangle, we can use SOHCAHTOA. So we know that sine of any angle theta is equal to opposite over hypotenuse. So we're going to do the sine of this angle, sine of 72 degrees equals opposite, which is the height, over the hypotenuse, which is 8.3. So we find the height using SOHCAHTOA. So go ahead and multiply both sides by 8.3. You can put this into your calculator. So you're going to do 8.3 times sine of 72. And that ends up giving us 7.89 for the height. Okay, so we need to know the height because if side A was less than the height, if 8.1 was less than 7.89, which it's not, then we would have no triangle and we would not be able to move forward doing anything else. We just say no triangle and we move on to the next problem. But in this case, because it is longer than the height, well, and also it's not equal to the height, so it's not that second situation either. It's longer than the height, but it's less than side B, so this is going to be that third situation. Let me see if I can get just to kind of model this. So it's longer than the height, but less than side B. So one triangle is going to be this triangle off to the side. The second triangle, whoops, I let go of it. The second triangle is going to be this one that looks like that. So it's still less than side B. So let's go ahead and get rid of that. Okay, so we could say here that because side A is greater than the height, but less than side B, we're going to end up with two triangles. Okay. So our next step, so after we find the height and we determine what situation we have, our next step is always going to be to find angle B using the law of sines. Okay, so let's go ahead and put this into the law of sines and just see what we end up getting for angle B, and then we'll talk about how that relates to our two different triangles. But let's just see what happens when we plug the numbers in. So sine 72 over 8.1 is equal to sine B over 8.3. Okay, so let's go ahead and cross multiply. 8.3 sine 72, we're going to end up dividing that by 8.1. So it was 8.1 times sine B, and then divide both sides by 8.1. So I just sort of skipped a step there in my writing. Because we're solving for an angle, we're going to need to do the inverse. I'm going to rewrite this here. Angle B will be equal to the inverse sine of 8.3 sine 72 over 8.1. So when you put that into your calculator, remember we're going to round to the nearest degree, we end up getting that angle B is 77 degrees. So if we think about the picture of our two triangles, this is an acute, that's an acute angle. So let's actually just draw out what our two triangles are going to look like, and I think that's going to help us to continue to think about this moving forward. Okay, so the first triangle is always going to look something like this. The second triangle is always going to look like that. So triangle 1 is always going to be an acute triangle with all acute angles. Triangle 2 is always going to be an obtuse triangle where one of the angles is obtuse. So what's the same about the two triangles is that angle A, the given angle of 72 degrees, that's the same. The given side length of side A is the same. And then the given side length of side B is the same. So those are the only numbers that are the same for the two triangles. All of the other measurements are going to be different. So let's think about this answer that we got from doing law of sines, 77 degrees. So we want to think about, would that make sense that it would go with the triangle 1 picture or the triangle 2 picture? And if you're thinking triangle 1, you're exactly right. Because triangle 2, this is an obtuse angle. It's greater than 90 degrees, so it wouldn't make sense for it to be 77. So we're just going to label the 77 over there for. Okay, and let's go ahead and label that angle B. So now we need to do some thinking to figure out how we're going to get angle B on triangle 2. So to help us think about that, I need to show you something over here. So remember when we found angle B from law of sines, this is what we typed into our calculator, and we got it to equal 77 degrees. Well, it turns out that the 8.3 sine 72 over 8.1 is actually, that's about 0.97. So it turns out that what we were really doing in the calculator is we were finding what angle has a sine of 0.97. And if you look at the picture here, sine is the y value. The height of our triangle, it's pretty close to the y-axis because it's almost equal to 1. 77 degrees, we can see here that has a sine value of 0.97. Remember the restricted domain for inverse sine? It was negative pi over 2 to pi over 2. So when the calculator is giving you an answer for inverse sine, it only has the ability to give you an angle that's within that restricted domain. But it turns out there's another angle in the second quadrant that also has a sine value of 0.97. If you think about reflecting that triangle over the y-axis, there's another angle over here that is going to be the same. So to get this angle, we're going to subtract the 77 degrees. We're going to subtract it from 180, and we end up getting 103. And so part of why we can do that, if you were to look at the angle measure on this side, that angle measure would be 77 because there's symmetry in this picture. So the angle measure from here to here is 77 degrees. So the angle measure from here to there is also 77. So if you take the full 180 degrees, subtract that 77 measure, what we're left with is 103. So it turns out that 103 degrees, this is going to be the measure of angle B in the second triangle. So let's go back over here to our picture and label this as 103 degrees. Now here's what I want you to write down as part of your notes, is that these two angles will always add to 180 degrees. Okay, so I showed you this picture here to help explain why that's the case. You don't have to draw a picture like that for every problem. All you need to do is take whatever answer you get for angle B. It's always going to be the acute angle that you get from your calculator. Just subtract it from 180 to get the other one. Okay, so that's a step that you really need to memorize. Okay, so now that we have angle B for each triangle, let's go ahead and find angle C. So we know that we're going to find angle C by subtracting the two given angles from 180. So in triangle 1, angle C would be 31. For triangle 2, angle C is 5. Let's also label that as angle C. Okay, so we found angle B in the first triangle. Subtract it from 180 to get angle B in the second triangle. Then we found angle C for both of our triangles. We're almost done. All we have to do to finish this out is find side C for both of our triangles. And we can do a very simple law of sines to get those two final answers for side C. So I'm still just going to do sine A over A as the given ratio. Now for triangle 1, my first triangle, angle C is 31 degrees. So we'll go ahead and fill that in, and we will cross multiply, divide both sides by sine 72. All right, put that into our calculator, and we should end up getting 4.4. Let's go back to our triangle here and label that side as 4.4. All right, for our second triangle, we'll set up our law of sines very similar, but it's a different angle for C. That's going to be the only difference. So it's still sine 72 over 8.1. But this time, in the second triangle, angle C is 5 degrees. Okay, type that into our calculator, round to the nearest tenth, and it's a little tiny side length. It's just 0.7, which kind of makes sense. It's just going to be a smaller length for the obtuse triangle versus a longer length at the bottom there of the acute triangle. Okay, so we have solved this. So we found all of the information, all of the missing information for both triangle 1 and triangle 2. Okay, so one last situation. First thing we always want to look at is angle A. We want to know if it's acute or if it's obtuse. This angle is obtuse because it's greater than 90 degrees. So if the angle is obtuse, it's pretty easy. There's only two things that we are thinking about. So if A is greater than or equal to side B, we end up with one triangle. Actually, that should be not equal to, but just if A is greater than B, it's one triangle. If A is less than or equal to side B, then it's 0 triangles. And this is just going back to that chart that we looked at the very beginning. So if we look at a comparison between A and B, A is less than B, so it's no triangle. To show a picture of what that would look like. So if angle A is obtuse, that's going to look like this, 170 degrees. This would be side B right here is 8. And then side A, if it's only 6, you can see here in the picture it makes sense. It's not going to be long enough to connect it. Now let's say you didn't notice this right away, or maybe you forgot. I just want to give you a little bit more proof for why this situation doesn't work. So let's say that we just started to move forward doing the law of sines. I want to show you what will happen with our calculation. Okay, so let's go ahead and cross multiply. Divide both sides by 6. Okay, so right here, if you were to actually just type in this left side into your calculator, you end up getting 1.28. Well, the sine of an angle, it cannot equal 1.28. It can never equal anything bigger than 1. If you try to do the sine inverse of 1.28, you're going to get a calculator error. It can't do it. It does not exist. So that's some further proof why that situation does not work. All right, so that is the law of sines. That's the end of day 2, looking at the ambiguous case, the side-side angle situation.